makes a building smart? I think it's a very interesting question, and one that means different things to different people and different players in the supply chain. So if we take it from IBM's perspective, what makes it smart? We're looking at it from two perspectives. One is as a corporate occupier. We have quite a large estate ourselves around the world. And we're also looking at it as what can we contribute as a business to the construction and maintenance and operation supply chain. So if we take it from IBM's perspective, we had a very strong interest in driving down our own sustainability impact, as well as our energy use, the costs and carbon effectively. And to do that, we instigated a program with industry partners around Lean Six Sigma techniques, on the basis that we'd already managed quite strongly our own estate. We're looking for new angles to it. So our perspective, given IBM's heritage, was we've done a lot of traditional stuff to the buildings. What can we do to exploit that data? Looking fundamentally at retrofitting buildings. We have been involved to some extent in new build, but particularly when we look at our own estate, we're stuck with what we've got. We can't change that estate radically. And our internal trials are focused on facilities in Dublin and in Rochester and Minnesota primarily, where we've got large facilities, huge energy consumption, and we've taken our own poison to a large extent. We've trialled what we're offering to our clients internally. We've driven down energy use following 10 years of an ongoing energy program. For example, in Rochester, we're getting 5 to 7% year-on-year savings, doing all the traditional things you do. By applying some of our technology, we've got a 15% annual incremental energy saving on the base of existing assets. So absolutely, we're focused to a large extent on the existing, which is somehow more difficult. That same approach is applicable in new build. And as a more specific example to here where we are today in London, we'll be rolling out the technology we've trialled in Dublin in the US to this building during the course of 2012.
So I think overall you can control pretty much anything. Work that we're doing with one of the hoteliers, for example, looking at Hotel 2020, looked right down at how could we change the characteristics of the room to match the personality of the individual. So if you imagine somebody coming in with the loyalty card automatically identifies them as they come into the room reconfigures itself to meet their personal needs. So the stiffness of the bed that they prefer, the temperature of the room that they prefer, the lighting that they prefer, the layout in the room if possible as well to what they prefer, making sure the right music's on, giving them access to the services that they need in the right kind of way. And that sort of automatic reconfiguration is very much possible through simple things like actuators and sensors that are embedded inside the room itself, through to access to a set of servos to drive different activities. So they're all there. Often we don't imagine what's possible, and I think the limitation today is that we don't often think enough about the individual that will be inhabiting that space and what their real needs are. And I think that's one of the places that we're really helping is ask some of those very simple questions of what is it we really want from this space, and then technology can then be provided to make pretty much most of these possible. We're looking at techniques for scavenging power, for example. So some of the work that we're doing looking at wastewater flows and trying to use that as scavenging power to then fuel some of the sensors and some of the measurement devices. So you no longer need to have additional sensors attached to them. So I think we're very much in parallel. We're very keen to find optimal designs which both infuse technology in a natural way, but also uses natural capabilities to be able to support the building purpose and building use.
I think from a technological perspective, we're looking to enhance what's out there. I don't think anything we're looking at ourselves is running contrary to any of the industry trends. I think another important issue though is looking at some of the cultural changes that are required to actually make sustainable design a reality at the end of the design and construction process. We touched earlier on things being designed out. I think a key area where architects can influence is right at the start, when having discussions with clients. The way the supply chain itself is put together, the way individual components of that supply chain are paid, incentivised, focused on the end goals. I think that industry cultural change is quite important as well, to make sure that the initial concept that people have actually becomes reality, not just during commission but throughout the life of the structure. So it's a difficult question to answer because the state of the art is constantly moving on. We're not seeing that flowing through yet. You probably need a few years of operation to see that embedded. I think what we would say is, given a standard building with a standard maintenance regime, we would expect to drive out probably around 30 to 40% energy savings and probably around 10 to 30% maintenance savings by implementing our bit of smarter buildings. So I think you'd need to build on that with what the rest of the industry can bring into their bits as well. It's a huge saving, but if we just simply look at our own experience, coming back to Rochester, Minnesota, the asset classes that we've monitored and we've focused on air conditioning units to a large extent, because that's where a lot of the energy is being used. By applying our analytics technology, we've driven down the amount of maintenance, the number of maintenance hours by 49%. I think this can go a very long way. I think we're already starting to see the possibility of smarter grid and what that can mean. And that could be intelligence within the building, knowing when to draw from the grid, knowing when to use renewables, either micro-renewables within the building or in the surrounding area. Then you've got the reverse. When can you feed back into the grid? When can you feed back into district heating schemes, for example? People already talk about the carbon neutral building, so we might not be that far away from the point when buildings are self-sustainable from an energy perspective themselves, so they're actually then contributing to the wider energy demand within society.
We're very careful in using the word smarter rather than smart, and the notion that we see this as an evolving journey. Every step we take, we start to find new connections, new ways of optimizing things. And nobody would have thought that by bringing transportation with hospitals together, as we talked about earlier, you could find new ways of optimizing, and you can. And as you've achieved that level of optimization, you find there's a much better linkage then between the power that might be in the electric ambulance with the hospital itself. And there's a new usage of some of the power that might be in either part of the building. And so finding new ways of connecting the value that exists in those assets is kind of key. So we see information as the way of helping us understand and see the world differently and find new ways of reaching high levels of optimization and innovation in the use of the buildings and the assets that we have.